Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be finding the absolute value of a complex number, which is very complex because z is a complex number given in polar form. We used Euler's formula, so it's more compact, but we'll expand it. And then we're supposed to find the absolute value of e to the power iz. And of course, that's the complex exponential, and it's going to give us another complex number, so on and so forth. Now, here's a couple of things to talk about. If we had a real number instead of the z, okay, a real number like, I don't know, theta, how about that? Any theta, any number will do, right? If you had something like e to the power I theta, by Euler's formula, this could be written as cosine theta plus I sine theta. And when you're trying to find the absolute value of this number, you could just use the absolute value, and then by definition, it's the square root of a squared plus b squared. In this case, this is going to be our a, real part, and imaginary part b. So the absolute value is just going to be the square root of a squared plus b squared. And that would be just 1, right? Trigonometrically. So, is that true for this number as well? Is it going to be 1? Well, not necessarily, because z is not real, right? If you look at z, you're going to notice that it actually has an angle, theta, that is different from 0 or pi, or any multiples of pi. Therefore, it's not going to be on the real axis. So how do you deal with something like this? Well, first of all, we can go ahead and expand z, and then just plug it in and simplify as much as possible. So for example, if I just plug it in here, I will be getting e to the power I times 6 e to the power I pi over 3, and then take the absolute value. That's not very helpful, is it? Because what is this product, right? I kind of need to figure out what that product is going to look like. So let's go ahead and do the following. By using Euler's formula, let's go ahead and write this in standard form. So how do you write 6 times e to the power I pi over 3? Well, 6 is in this case, by the way, is the modulus or the absolute value of z. But remember, we're supposed to evaluate the absolute value of e to the power iz. So we're going to multiply z by I and then raise it e to the power, or exponentiate it. Okay, how about that? So this can be written as cosine of pi over 3 plus I sine pi over 3. Okay, what is cosine of pi over 3? It's cosine of 60, which is sine 30, which is 1/2, and this is root 3 over 2. If you distribute the 6 from here, you're going to get 3 plus 3 root 3i. So that's going to be our z, okay? And then if you are wondering what iz is going to look like, e to the iz, it's going to be e to the power I times 3 plus 3 root 3i. And then we're going to go ahead and distribute the I. That's going to give us e to the 3i plus 3 root 3i squared, but I squared is -1, so there's no need to write it. And we can kind of write our number like this. So what is that supposed to mean, right? This is a number that is written as an exponential, but let's go ahead and separate it. So I want to write it as e to the power -3 root 3 times e to the power 3i. And then if you think about this number by using Euler's formula again, e to the I theta is cosine theta plus I sine theta. In this case, your new theta, or you can call that alpha, I guess, right? E to the I alpha is just going to be cosine alpha plus I sine alpha, right? So this is going to be a number whose modulus is 1. Therefore, the other number is the modulus. Let me explain what I mean by that. So we can go ahead and expand this as cosine of 3 plus I sine of 3. Obviously, if you take the absolute value of this is going to give you a 1, and this will be the absolute value. Make sense? I hope it does. Let's go ahead and take a look at it from a more general perspective. So whenever you're given something like e to the iz, how do you find the absolute value? What does this number represent, right? So z can obviously be written as a plus bi, right? And when it's written that way, you basically have something like I times a plus bi. And then in this case, I assume that z can be written as a plus bi. And then this gives us e to the power -b times e to the power ai. Not artificial intelligence, just the number. okay, the complex exponential. So here, as you can clearly see, e to the power negative b is going to be the modulus. So this is what you're looking for. The absolute value of e to the iz is basically the number in front of this e to the power I theta thing. So in other words, we can basically say that if z is a plus bi, then the absolute value of e to the iz is equal to e to the power negative imaginary part of z. How do you like that? That's just a formula that you can pretty much apply to any situation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.